So thanks very much for coming here tonight. Java 8 is the most exciting release of Java ever. So anything that's ever been released in Java before is not as good as Java 8 by definition of it being Java 8, right? Hopefully until Java 9 and the rest of future releases will be just as good. So the plan tonight is pretty simple. There's a lot of topics to cover, lambdas and streams. And what I've assumed about you guys is that you want to learn those topics, that you're familiar with the Java programming language. But I don't assume that you're necessarily an expert in lambdas or you've done a lot of lambda programming with other languages. So I've tried to keep the presentation as clear as possible. If your goal is to master those two topics, then at some point you're going to have to learn all of the concepts that I'm going to have on the slides. And so if you just pay attention tonight, you'll walk out of here with a complete understanding of everything you need to know to go on to and say, okay, let me look at the more advanced use cases that I can apply lambdas and streams in Java 8 for. Having said that, I'm going to give you this little disclaimer. Some of the early slides are going to provide incomplete definitions. The reason why I do that is just to keep things simple so it's easy to follow along. By the end of the presentation, those incomplete definitions will become more complete. Okay? So don't get worried if you happen to know what's on some of the slides and you're like, he's wrong. That's intentional. So I welcome questions. Ask them as we go along. And I don't promise to know the answer to every question you might have, but I'll do my best. So just a quick survey here. Raise your hand if you've used lambda expressions in the past in any programming language. Doesn't have to be Java. So that looks like about 40% of the room is what I'm guessing. Raise your hand if you've done programming with streams, not just in Java, but in any other language too. Counts. Okay, so a few people. So if you are new to, if you've done all of this stuff before, what you're going to learn today is just how Java 8 does it. Very simple. There's not going to be any new concepts for you to learn. If you haven't done this stuff before, then there's both concepts and also how Java 8 does things. So let's first start out, talk a little bit about the concept of lambda expressions, syntax, functional interfaces, variable capture, method references, and default methods. These are all things that were added to the language, which will allow you to build things like the Streams API and many, many other things. You know, Java 8 brings functional programming to Java as much as that is possible within the constraints of staying backwards compatible with previous versions. A little bit of history about lambdas. They're actually very old. They're ancient. They're from the 1930s. And they made their way into programming languages in the 1960s. And practically all programming languages have them. C++, C#, JavaScript, Python, Ruby. And now, finally, after many years of waiting, so does Java. So we're no longer lambda-less. So what is the lambda definition of it? Your typical thing that's given is this is probably you've seen it, even if you've never, if you type it into Google, you'll get something that looks like this. It's a way for defining anonymous functions. You can pass it to variables, pass it to functions, you can return it, and you're probably wondering, so frickin' what? What if I could do all things? What does that get me? The answer is there's a lot of things that it gets you, but I'm not going to talk about those today. So if you're interested in, but other than just what's on this slide here, which is to say that it is the basis of the functional programming paradigm. Functional programming is a very rich paradigm, just as rich as object-oriented programming. If you are not familiar with the functional programming paradigm, who's new to that? Raise your hand if you're new to that. All right, 5 brave souls. Thank you. Then at some point, you're going to have a functional programming birthday. Okay? Just like you had an object-oriented programming birthday, your object-oriented programming birthday was the day that everything clicked in about classes, objects, inheritance, polymorphism, and it all became really obvious why that was a good idea, or became obvious why it wasn't a good idea. So, in the same scheme of things with functional programming, it has its own design patterns, it has its own techniques, and you're going to have to learn those, and those will be possible to implement with Java 8. So the big things is that it does make parallel programming enormously easier. So if you want to keep hundreds of cores busy, it's a lot easier to do with functional programming than with object-oriented programming. You're going to write more compact code, much richer data structures. There's really interesting things you can do in that area. And you can develop a lot cleaner APIs. And you'll start to see that when you look at things like streams and how they clean up working with Java utils for collections. So having said that, there are many presentations online, a lot from the Java one, that talk about why lambdas are useful, and you can go watch those. Another key thing here for tonight for us is to understand that there is the concept versus the implementation. We know this because we have things like maps, and you have multiple implementations of that, like hash map, concurrent hash map, or lists. And by the same token, lambdas are a concept, and it has different implementations of in different programming languages. So if a programming language was built from day one to include lambdas, those lambdas are probably going to look a little bit nicer than they do in Java 8. Java 8 lambdas are the Java way, the way that's backward compatible to do lambdas in Java. So there's two distinct things to focus on. One is the general concept of lambda expressions, and then the Java 8 implementation. And here's my learning tip if you're here, is that if this is your first encounter with lambdas, then recognize that you've got two things to learn, both the concept and the implementation in Java 8. And that's going to be a steeper learning curve for you than it would be for somebody who is already familiar with lambda expressions from a previous programming language. So that covers all the background. Now we can dig into how Java 8 does it. So I'm going to keep the programs really simple, on the order of let's make them so simple that if you can follow Hello World, you'll be able to follow those. I want you to be able to focus on the concepts and not get tripped up by how clever I've made the programs appear to be. So here's a list of integers, and all I want to do is I want to print it. But I don't want to write a for loop to print it. So I'm going to call the for each function, and I'm going to pass it a lambda expression. And the lambda expression here, you can see that it is this x arrow system out print ln x. And what that is, it's a function which takes a parameter called x and does something with it. But unlike a typical function you write in Java, hey, what happened to my curly braces, right? They're missing an action. What happened to my types? What's the type of x? Interesting question. So what I want to do before I answer those questions with a lot of simple examples is to look at just a little bit more of the syntax so we can get that out of the way. Any questions at this point? Right, so here you go. If you want to put curly braces, go ahead and do that. You can make a 20-line, 50-line, a million-line lambda expression. Java won't complain. So you can do that if that makes you feel better. However, for what's really great about them is the notation on the previous page, which is the single line one. It's quite compact. And you'll find yourself, when you really wanting to use that rather than necessarily the curly brace version. Just like any function, you could define local variables. You could do whatever you want in there, nothing really fancy or interesting. You can see here, we've got this extra int y equals 2x/2. You can also specify the types optionally. So if you are looking at, hey, how does this look like a function, you can see that the for each now, we've got the extra open bracket, open paren, integer x. So we told the for each function that what we're passing it is of type integer. Now, you don't really need to say that because Java 8's compiler is able to do type inference. So Java 8's compiler says, OK, let me look at integers. What is the data type? It's a list of integer. So if I'm going for each over a list of integer, well, what am I going to pass to the lambda expression? An integer. That's why the type is optional. Okay? And if I'm going too fast, wave at me. There's a lot of slides I want to get through, but going through too fast will not serve you or me. So with that said, let's think a little bit about the lambda expression that has a life cycle in a way. And the lambda expression life cycle is the compiler sees a lambda expression, and what it's going to do, it's going to turn it into a function. Okay? And once it turns it into a function, then the next thing, it has to figure out how to call that function. And so what I want you to think about it is like this. So take a few seconds and read that while I drink some more beer. All right, who can, in their mind now, can say, question?
It generates a static function instead of making it part of the integer reference.
So the question is, does it generate a static function? That is the best way I've found to think about it. Yes, it will, and it can generate a static function. If it generates a static function, that gives it a really fast implementation because the invoke static bytecode is super fast. And will, like, the specs don't say anything about how the Lambda is implemented. And what they've promised is that for the initial release of Java 8, they're doing the implementations that are the easiest for them, but they fully intend to optimize them enormously. And it also depends kind of what you're doing in the Lambda. So I don't want to get into too much detail about this. I'll circle back to this when we cover variable capture, because that will impact whether you generate a static or something else. Okay. Great question, thank you. Did that answer your question?
Yes, thank you.
Okay, great. Anybody else? Okay. So takeaway point, you see a Lambda expression, put curly braces, copy whatever's outside the arrow, stick parameters on there, and think of it as a static function, okay? Always, no matter what, think of it as a static function. So what is the type of this Lambda? Is probably what you're thinking. If it's an expression, it has to evaluate to something. If it evaluates to something, it's got to have a type. Does it evaluate to a primitive? Does it evaluate to an object? What exactly is it? And the answer to this turned out to be a very difficult one to answer for Java. Many programming languages, they define a function data type as a native function data type. And that was considered by the Java 8 designers, but they rejected it because if they defined a function data type, there were going to be a lot of problems with backward compatibility. In particular, type erasure was going to completely make it very, very difficult to use. And all of the details about why they implemented it the way they did is in this really fantastic presentation, which is Lambda, A Peek Under the Hood, by Brian Getz from last year's Java 1. Has anybody here watched it? No? If you haven't, watch it. It gives you all of the background thinking that went into why is Lambda the way it is in Java 8, how does it work, how does the compiler generate stuff. So yeah, so you can do that. So in terms of this implementation, how does this thing get implemented? So we saw we take the simple Lambda expression, we generate a static method from it. Well, can you hang a static method just by itself in a class file? Anybody? No. It's a class file. It's got to have a class. There's got to be something to hold that static method. Well, what is that class that holds that static method? And how would you create instances of that class? And would a static method work on all situations? Are there situations where you need instance methods? Again, I don't want to get into all of those details. Those are really fascinating and interesting details, but they're probably for a future talk at this jug. But watch that under the hood, which answers all these questions. For now, please think of it as that. All right. So now that we've learned what that is, the syntax a little bit, let's take a look at a very important concept: functional interfaces. Right. So this is a term that you'll get to become quite familiar with. So here's a functional interface. It's just a regular Java interface which has a single method. Okay? This is a common idiom in Java code. So let me prove that to you. Runnable, right? Is an example of a functional interface that has existed forever in Java. It just does what it's supposed to do. Comparable, right? Callable. So in your own code, who's written interfaces with a single function in them? Raise your hand if you've done that. Okay, that's quite a lot of the room, right? And so one of the things they wanted to do is make sure that the Lambda expressions would work with all the code that you've already written without ever having to recompile it. So they said, let's take what people do today without, like prior to Lambdas existing in Java, they said, what are people doing when they want to represent the idea of a function? Well, people go and they write an interface with a single function. And that's how they represent the idea of a function type. So let's just formalize that into the language, and we'll call that a functional interface. Here's some stuff from the popular Spring framework, like transaction callback, row mapper. map a result set to a row, or the statement callback to execute something within a statement. So if you look even at the wider ecosystem of popular Java libraries, you're going to see this pattern over and over again. So they officially decided that they need to support it. So let's take a look at an example of that. So here's an interface called consumer. It's got a single method called accept, and it's supposed to do something with it. Here's how you could code a for each method. Imagine that this for each is inside of some sort of like array list container, as an example in your mind. So it's just going to have a regular for loop over some set of items, and then it's going to call action.accept. So from the point of view of the user, of the end user of a Lambda expression, it just looks like an interface. Let me actually show you the rest of the code. So in this example here, I've got my list of 5 integers, and I'm going to create a Lambda expression, and I'm going to assign it to an instance of consumer. So when I called for each earlier, right, the for each didn't, it was just like we passed it the x arrow system out print ln x. In this example, we're assigning it to this consumer integer consumer. So didn't I just tell you earlier that this was a static method? How can you attach a static method to an object? Kind of weird, right? This is where all the magic of invoke dynamic comes into the picture. And what they do is the basic idea is that the right-hand side of it is the body of the function that is defined, whose signature is defined in the functional interface. Since the functional interface has one method, that one method in the functional interface is the signature of the body that you're attaching to it there. Am I making any sense?
Say that again.
OK. So when you write a function in Java, you start up by typing up the function signature, right? Then you put a curly brace, and then you type in the body of the function. So what we're doing is we're separating that out now. So the body of the function is, we're putting that in a Lambda expression. The name of the function is not important to us because we're dealing with anonymous functions. What is important to us is the signature. What parameters does it take? What does it return? And what exceptions does it throw? Well, if we look at the consumer, at this interface called consumer, we can see that it takes a parameter of type t. In this case, that's an integer, because that's what the generic is pointing to. And we can see that it does not return anything, and it throws no exceptions. So it's like you're defining the function in 2 parts. The signature is in the functional interface. The body is in the Lambda expression. Comments, questions? Yeah, go ahead.
So if the consumer had a second method in it, would that be a compilation error?
That's a fantastic question. Just wait for the next slide. Anybody else? Any other questions? Yeah.
Does that mean that Lambda can only ever have a single method parameter or a single argument, and then it always void return type? So you can return anything?
OK, so the question was, does this mean that the Lambda expression can only have a single return, accept a single parameter and return nothing? In this case, yes, that's what it means. If you had put this as a different interface, let's say the method was returning something, then you could return something from the Lambda. Let's say it took 5 parameters, then you would have x, y, z, blah, 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 a, b, c, d, e, f, right? So that's it. Yeah?
If you violate that question, if you violate both of those, is that a compilation?
Yeah, you'll get lots of compilation errors. Lots of new compilation errors to decipher. So, and ponder over. So this is the integers that for each. I guess I should have clicked the things a couple more times. OK. So now you're probably wondering, if you showed me that it's just an instance of an interface, couldn't I have just put an anonymous inner class on the other side? Who's thinking that? Bonus points, you're ahead. Yay. So you're probably thinking, isn't the Lambda expression just an anonymous inner class? The answer is no, it's not. But I can't tell you all the details yet, because that will make things not as easy to understand. So in 20 minutes or so, you'll know why and how exactly they're different from anonymous inner classes. So here is how you can get the compiler to assist you. The earlier question was, hi, can the compiler help me out if I make a mistake and define more than one thing? The answer is, just like there's @overrides in Java 5, and you can do that to catch your bad typing mistakes, there's an @functional interface annotation. And what the compiler will do is, if you have more than one method on the interface, it's going to tell you that the code doesn't compile. So in this example here, it's not a functional interface because I have this extra do something else method. And this is what the compiler will say. You can read the compiler error message right there in red while I drink more beer. I hope I don't run out of beer while you're reading slides. Correct. So the @functional interface only works on an interface. It does not work on a class. So this is, for me as a longtime Java user, I'm really happy about how they did this, because it means that all of the code that's ever been written that is already using functional interfaces without even calling them functional interfaces, all of a sudden you can pass out a Lambda expression. And we'll see some nice examples of that. So from a backward compatibility perspective, this is awesome. From a, is it as cool as other languages? Let's not go there. OK? It's an optional annotation. You don't have to put it on there for something to be a functional interface. The fact that it's a functional interface is just purely based on the count of things. So what this means is any interface, even if you compile it with Java 1.0 compiler, is still a functional interface if it has one method. Who's happy about the backward compatibility other than me? Who's like, no, backward compatibility, evil, kill it? Right? Yeah, kill it. Backward compatibility is very important. I have quite a few clients who are no more fans of Microsoft because of the few times they've broken backward compatibility. So Java 8 Lambdas will work with all the libraries. You don't even need to recompile the libraries. They'll just work. You can pass them Lambdas. I really love that. So here's an example. Okay, here's something that you might see in a Java EE application, perhaps like something using Spring. We've got we want to go to the database and read all our products, and we are needing a row mapper. And the row mapper is being created via an anonymous inner class. So we're implementing the map row method and then just going through extracting the things from JDBC, creating like a POJO and returning it. Okay? If you search through enterprise Java code, you'll see a lot of stuff that looks like that. So this is a situation. If you took this library and you didn't touch it, you just compiled and linked against it from a Java 8, you could do this. Yeah, so the comment was you don't need the functional interface annotation on an interface for you to be able to pass a Lambda to it. Anything that has one method, you can pass a Lambda. Question? Yes? What about an abstract class with one method? It's not a functional interface. You can't do that.
Can you back up? Just so
Yep.
See a result set and an int row. Okay.
Yeah.
And we have map row, but you don't even need that.
Yeah. So basically.
Product, you don't need that.
Yeah, so the difference between the two pieces of code, if you actually look at them, all the code inside of the body is the same, which is your whatever business logic extract from the result set of the query the parameters and create a product object and then return that. And then the template query method is the one that's actually taking as its first parameter, in this case, it's taking the SQL query. And the second parameter is an implementation of a row mapper. And what the row mapper does is it's given a result set and a row number, and it returns an object. And this thing collects it and returns it all as a nice list. So when you sit and you type this, like what Lambdas are doing for you in this case for this old library is it's just saving you a little bit of typing. You don't have to use an anonymous inner class. You just can do it with a Lambda expression. And the Lambda expression, you can see in this case, the Lambda expression is taking two parameters. I've put the data types on there just to make it more readable, comparable to the old one. Yes, go ahead.
Where's the throws clause?
You don't need the throws clause on here, but if the type signatures don't match, okay. So the question is, where is the throws clause? What happened to it? The previous code had a throws SQL exception. So what happened to it on the other side? So in this case, because we're doing the anonymous inner class, we have to replicate, by the rules of the compiler, the actual signature. In Java 8 is all about inference. So it's like, look, we know that this body of the Lambda is the body of the like the signature that this body is attached to is defined by the functional interface, which is a parameter on the query method. Therefore, if that throws an SQL exception and your code from in here throws an SQL exception, no problem. If you throw something other than an SQL exception, it's going to barf. If you throw like an IO exception, it's going to say, well, the Lambda, it doesn't work. You can't even do it. You have to modify the functional interface. Does that answer your question?
Does template query?
Okay.
Is it defined as throwing an SQL exception? Is that why it bubbles up and it's?
Yes, because the reason why you have to put this one here is because when you call like rs.getDate, that operation throws a SQL exception. Who's confused about that? Anybody here? I can quickly do some coding, some live coding. Anybody want to see some live coding? Are you clear about it? Okay, 2, 3, 4, 5. Okay, let's just demonstrate that. So let's go here to Eclipse. Oh, this is not my main Eclipse workspace with all of the. And I'm like, why is this not working? I'm 10 times faster when I'm typing stuff. All right, we'll just do system. We'll do it the hard way. What is the compiler saying here? Yeah, that's right. There's no parameter here. So let's do it like this. See, I shouldn't be drinking beer while I'm talking. So we'll do throw new IO exception here. And now it's going to say unhandled type of IO exception. If you ask Eclipse to quick fix it and you do add throws, it's going to add throws on the enclosing type, not on the functional interface itself. Does that clarify it for you? Okay. So basically, the takeaway point, kind of going back to the slides here, is that what we're doing is we're doing two things. One is we're defining the signature of the anonymous function in the functional interface. The body is in the Lambda expression. All right, so I'm going to show you another example here, and it's just a self-check if you guys got any questions. Go ahead.
So is it possible to define a method that takes a functional interface without creating a Java interface to map to it?
Sorry, say that again.
I want to have a method that can take a Lambda.
Yeah.
I don't want to create a Java interface to represent it. Is that possible? Because you said there was no function type method.
Right, so the question is there a way for me to define something that's going to take a function, that's going to take a Lambda, but I don't want to write the functional interface myself, is your question. The answer is use somebody else's interface. And in the Java 8, I'll show you later, there's a new package called java.util.function, which has, I think, about 43 separate commonly used, commonly occurring signatures. Yes,
have
question?
an overloaded method with two different interfaces as parameters, and will the compiler figure out which one?
Can you have,
So say you have an overloaded method, right? The same method name, and in one it takes a parameter of one interface. The other method takes a separate interface. You just want to write a lambda.
yes, so long as the signatures are compatible and it can derive them, it will work. So for example, can I park that? Yeah, that's a really good question, but yeah, we'll come back to it, okay? So let's say you've got this password encoder, which has an encode method. You have now a function. Please check, what is this function returning in this case? It's returning an object or a Lambda expression. Who says it's returning an object? Raise your hand if you say it's returning an object. Raise your hand if you say it's returning a Lambda expression. And raise your hand if you don't want to vote. So I'm getting very little participation here. Do I need some prize incentives? So in this case, you can see that what we're doing is, again, we have a Lambda expression that we're using to actually make an instance of a password encoder. And that instance of the password encoder, the body of the implementation of the one method in the functional interface is going to be calling password to uppercase. You see how cool my encoder is? This is way better than Heartbleed.
That's legal, right? You don't have to,
This compiles. This works just fine.
you don't need
Yeah.
an encode method anywhere in your password. You
No.
take that encoder.
No. Go ahead.
For the purpose of an analogy, would you be able to say what it's doing there? Like say it's boxing your Lambda expression there to create the password encoder?
I wouldn't quite
More of
use.
a stage, less
Okay, so the comment was, would you say that in this case it's boxing the Lambda? I wouldn't use the term boxing because boxing to me implies that there are two distinct different types, like integer, like a primitive and an object, and going from one to the other with boxing and unboxing, unless you have a different meaning of the term. That's what it means to me in the context.
That is what I mean. It's just this stage. So when you say, you're asking us the question, is it returning a Lambda expression or is it returning the object?
Yeah.
The same way I would be wondering, is it, if it was doing something like you're returning like an unboxed integer from a method that returns.
Right. Okay, I get your comment now. Okay, so in a case like, for example, it was returning an int and you returned an integer object and it did the conversion. Yeah, there's something the compiler is doing there. The compiler here is turning this into an object where the implementation of that is going to be a call to that password.to uppercase. Question in the back?
You answered one, it is in fact returning an object.
Yes.
It has to be a Lambda expression.
Yeah.
But can I enforce, for example, final parameter?
Where do you want to put final? You want to put final on the password or the salt?
The interface, for example, I might say final string password, final string salt. But many static checking tools don't want you to modify parameters to function.
I see what you mean. We'll see some slides on that. Okay. So here's we saw an example in the make bad encoder of how to use a Lambda expression as something that is being returned from a function. And in this do something method, we're seeing how to use the Lambda expression and call it. And that looks like every piece of Java code you've ever written. There's no trace of Lambda here. If you take this do something method and you show it to somebody who's not here today, who doesn't know anything about Lambda expression but knows Java, they'll say, yeah, that's just a method that takes a type. Okay? And then you can just create it and call it. So anybody got any questions about this? Yeah, in the back? The second one being this guy here? What is this function called? That's just called a regular Java method that returns a password encoder, but it's just how we are generating the implementation. If we didn't have Lambda expressions, somewhere inside of here, we probably would have had to do return new and then some object, right? Return new password encoder impl. Return new, I don't know, what's a popular one? SHA-512 password encoder or something, right? So that's what you would do in this case. Or return a bcrypt, new bcrypt, and you'll pass it the parameters. In this case, we're just actually returning the body of the object method there. Comments, questions? Does that clear it up for you? Great, thank you. I love the questions, by the way. I really appreciate that. Anybody else got any questions about this?
What is the output of that? Do something last slide.
What's the output of this? It's going to be A, B, C, all capital letters. Because what's going to happen is when we call do something, okay, so password encoder here, we called the make bad encoder, which is going to return this, an object which has one function in it, which is the encode. And that encode function, the implementation of it, just does password.toUppercase. Since we're passing it in the do something method, since we're calling encode with ABC, it will print capital A, capital B, capital C. Does that answer your question? Yeah, great. Yes, go ahead.
So in this particular implementation, does this have any performance benefits over just doing a new password encoder inflow and writing that?
Okay, so the question is, does this have any performance implications over calling new, right?
Can you mention the garbage collection?
Okay, so I'm going to give you a very short answer. Watch Lambda peek under the hood. Okay, I won't do it justice if we got into it right now. The slightly longer answer is, if you use anonymous inner classes, you're generating a lot more garbage. If you think of the Lambda as a static function, then they're going to use invoke dynamic to make an object that wires directly to that static function call, and that's going to involve very little garbage collection, and it's going to be very fast. However, since the spec doesn't say how this should be implemented, a lazy implementer of this of the Java 8 compiler could return an anonymous inner class at that point. So I don't know the performance implications that will to be determined. Yeah, but watch that under the hood. Yeah. Question? Yeah. Oh, you mean that? Okay. Okay. So the question is, let's say I have another Lambda expression somewhere else that does password.toUppercase, right? Would it generate the same thing? I have no idea. You'd have to use Java P to look at the bytecode. I suspect that the current compiler doesn't do anything that fancy. Okay. Great. So in summary, please read this while I drink more beer and degrade my abilities to live code. Yeah. Okay. You asked me a great question. I'm going to do live coding and show you what the stack trace looks like. It doesn't look pretty. Great question. All right. Yeah.
Probably sort of not very practical. If I call equals on that function and got a second function.
Don't do that. Think of it as a static function, as a static method.
But the question is, what if I would start storing those functions in some hash table and all that stuff, and I need a good indicator, right? That's what people do.
Right. Yeah, you know what? I haven't really thought very hard about that. So that's going to be one of those questions I'm going to say, I don't have a good answer for you today. Right? But it's great that you're asking that, and yeah. I think the intention behind them isn't to kind of do that with those things. You typically are going to pass them to a function and just invoke it, do something. I can't think of a reason why you would put them in a hash table, but that doesn't mean that you may not want to. Maybe you stick them then in another object that just references it, that does have equals and hash code, a wrapper type of some kind. Okay, anybody else? Any other questions? Yeah, go ahead. Yes. The question is, can I have something of type object, and then you want to invoke the Lambda expression and assign the result to that?
No. So I just say object equals, and then X arrow.
Oh, right. Okay, so you want to write object equals to X arrow? No, because there's no function signature for the, because remember, the Lambda expression defines the body of a function, and you need to attach that to its signature. And if the left-hand side has more than one method, the compiler will get confused and say, what do I actually attach it to? I have no idea. Yeah.
Say object equals make bad encoder, but then
Sorry?
you could say object equals make bad encoder, but you wouldn't be able to invoke it, right?
So if you said object make bad encoder, like here, you set object here, that's fine.
Yeah, but it wouldn't do you anything.
Yeah, it's just you'd have to cast it back. Okay. Right? Like this is, okay. All right, so I'll assume that this is, we can kind of move on from here. So we've talked now, hopefully you're understanding the idea of a functional interface. It's how you interact with lambdas and call them, and how you define their signatures. So let's take a look now at variable capture. So the lambdas are going to be useless if they can't see the things in the code surrounding them. And so lambdas can interact with variables defined outside of the body of the lambda. And using variables outside the body of the lambda is typically called variable capture. So you'll start seeing this word floating around in the docs and stuff like that, the capture word. So here's a simple example from that. We'll stick with our simple 1, 2, 3, 4, 5 list. And what we're going to do now is just say we want to print out x plus var, right? Everybody can see that? Totally simple. Prints out 11, 12, 13, 14, and 15. Any questions about that? See, it just works, right? Now let's try changing the var inside. So we go in here and we say we want to do var plus plus. All right, let's have a thing. Who says you're going to get a compiler error? All right, a few people. Who says this will work? Raise your hand. Who's like, I have no idea. I need beer. You will get this compiler error. Please read the compiler error. Same for anonymous inner class. It says the local variable var defined in an enclosing scope must be final or effectively final. So what the compiler was doing in this slide here is saying, hey, nobody changes the value of the var. It's as if you had typed the word final in front of it. But since you didn't, I'm not going to make you go back and type it. I'll just infer that it's actually final. Yes?
Is it still inferred as final after the execution of the function?
You mean like that?
Yes.
Yes. So in this example here, and I'll just go back and say, let's try to trick the compiler. We'll set var equals to 50 here. And the compiler will say, error, local variable var defined in an enclosing scope must be final or effectively final, right? Comments, questions? All right, so how about static variables? You can do that too. So all I did was just exactly the same code, but I just moved the var out into a static variable. Comments, questions about that? How about instance variables? Yes, sorry, there was a question back there. Right, OK. So let me try to repeat the question. I'm going to paraphrase it. So the question is, if we go back to, say, this point here, you're saying that if you were using Spring or some other tools, you can write legal code and then go and try to change something, right? Yeah. That's what you're saying. So remember what I said, that you would take this code, and what are you supposed to think about the Lambda expression as a static function? Okay? So if you were to translate this into a static function here, how many parameters would you have on the static function? Okay, 2. Okay, what are those 2 parameters? The x, which is of type integer, because the list is an integer, right? And the second thing would be var, and it would be final. So the signature that you would generate from this would be something like the following. Just to make it concrete. Right?
The value would be the one at runtime at the call. So the value could change from the source code to another thread, for example, if it weren't final on the outside. So if it's effectively final.
I'm not sure I'm understanding your question here. So you're saying if this is not being treated as effectively final, the value wouldn't be var equals to 10?
Right, but it's not actually final, so there are a number of ways I can change that.
Right, okay, so if in the case of a primitive, it's harder, but if it's with an object type, it's the reference that you can't change. But you could call methods on that object and mutate it. Right, just like you can with an anonymous inner class. So think of the rules here as the same as anonymous inner class. Yeah. Question? You know, those are all the edge cases. Let's leave them for another talk, okay? So we did that one. Okay, so that leaves us the fun part here. Okay, you need to be awake for this part. Everybody, if you're feeling sleepy, tell the person next to you to punch you in the face. Or spill your drink on your neighbor's laptop. That should wake you up. Oops. Right, so what happens with the this pointer, right? What happens if you go this dot something inside of a Lambda expression? So let's say we've got a class called example, and notice that I've created an instance object there. And this instance object, now we've got a private int var, and we've got a private list of integers. So everybody clear on this? Now we're going to have our method called doSomething. And we are going to have a main method. And what our main method is going to do is just going to do instance.doSomething. Everybody following the code so far? Okay, good. Now we're going to call integers.forEach. And inside of it, what we're going to do is x arrow. And we're going to do this dot var. All right, so this code compiles. So what does that tell you about what does the this point to inside of the body of the Lambda expression?
There's no this inside of a static method.
Oh, there's no this inside of a static method, but I could pass it as the first parameter. So remember, the compiler is generating that method. So that hopefully tells you that the this is actually the this of the enclosing scope. You're not, unlike an anonymous inner class, which would have its own this, the this inside of the Lambda is gonna actually point to the outside one. So if you actually do if this equals to instance, this will actually print out that they are the same. Right? Comments, questions about that? Who's starting to see the difference between a Lambda and an anonymous inner class? All right. I'm glad you were patient and let me actually wait till this point to explain that. Any questions? So if we now say, OK, let's take a look at what happens if we did exactly the same thing. Remember, the for each is expecting a consumer interface. So we could actually rewrite this code like that. So now all I did was it's the same outside structure, but inside I've got a new consumer integer. And I'm overriding the accept method. And I'm calling int. Now, if I say in here, I can't say, if I want the var that's outside, I have to say example.this.var right here, example.this.var. I can't do that without, like the way I did with the Lambda expression. Who's had to write this kind of code to get the this on the outside object? Yeah, it's kind of fun, right? And the other thing that you see here is you see that I've got a private variable that's inside of the anonymous inner class, right? You cannot have that inside of a Lambda expression. There's no ability for you because the Lambda expression is just the body of the signature defined in the functional interface that the Lambda expression will be assigned to. And that always happens because either you assign it to a variable, or you pass it as a parameter, or you return it from something. And in all those three cases, there's a type. Okay, comments, questions about this? Yes?
Example.this.var legal syntax in Lambda.
Which one?
If you took the example.this.var and replaced it.
This one works. This is perfectly compilable, runs and everything.
Okay, but could you put example dot?
Oh, could you put, you know what? I didn't try that. So I haven't tried it. Yeah, I haven't tried that one. Right. So lambdas versus anonymous inner classes. Now we can talk about why they're not the same. First of all, the inner classes can have state, which you cannot have in the lambdas. They can have as many variables and objects inside them as you want. The inner classes can have multiple methods, right? You can have 5 methods in your anonymous inner class, no problem. With the lambda, you have 1. And finally, the this pointer behaves differently between anonymous inner classes and lambdas, which tells you that lambdas are not the same thing as anonymous inner classes, although the compiler could choose to generate an anonymous inner class for every lambda instance, which would not be a very efficient way to do things. But it could. Comments, questions? So that takes us back now to Java util function. So we now know these functional interfaces exist, and the question becomes, do I have to define this interface? Like, how many times do you have to define? I have something that, I have a function that takes an argument of type t and returns nothing. You don't have to go and define that interface. You could just use the consumer interface that's part of the Java util.function. Or maybe you have a function that takes no argument and returns something. Then you would use supplier. Or maybe you have a function that takes an argument, returns true or false. Then you would use predicate. Or maybe you have a function that takes an argument and returns an argument. Then you would use function of t comma r, right? So for the most common cases that you will run into for I need a lambda that takes something and returns something, look in Java util function before you go off and code your own interface. Everybody clear about that? Okay. So that takes us through, we've learned the syntax, what a functional interface is. We learned how the lambda interacts with the outside world. The next thing is method references, which is this problem here. So the lambda is a way to define an anonymous function, but hey, what if I already have written the function somewhere else? Do I have to rewrite the function just because I want to use it as a lambda? There should be a way for me to be able to take an existing function and pass it to a place where a lambda could be passed. And that's what method references do. So let's see some simple examples. Again, now I've got this static do something method, and all right, so here's what we have. So we have this do something method, and we want to call it. So one way to call it is I could define a consumer, and I can say x arrow do something, x, and then when you call consumer.accept, and it's going to print 1, because we passed 1 to the accept function. Hey, who's understanding how this code works? Raise your hand. Everybody else is sleeping? OK. I should. All right. But that would be pretty boring, and it's kind of a bit redundant. So instead, what you can do is you can just say example, : do something. And what that says is, I would like you to take this consumer interface, take its functional, take the method, the single method that's in that consumer interface, and I want you to use, for the implementation of that method, use do something. Who's with me on that? Comments, questions? Yeah, question in the back? Yes, in this case, we are referencing a static method. There are 4 different types of method references, and I'll give you an example for each one. Okay? Yes? Okay, so the question was, if the do something accepted more than 1 parameter, that's not the issue. The issue is what it returns. That's your question?
Really, yeah. It doesn't matter if it takes 2 integers.
No, it would definitely matter. If it took 2 integers, it wouldn't work. Because, again, what you have here is the left-hand side is the one that's specifying the method signature. Inside of the consumer has a single method called accept, which takes a parameter and returns nothing. A single parameter. Therefore, you can use a method reference for anything that has 1 parameter and returns nothing. And the parameter type must match this type right here. So because we said it's a consumer of integer, if we had actually changed to do something to take a string, this would not compile. Yeah? Good question. The answer is you got to still do the wildcard business and all that stuff. You can get really complicated looking expressions. Okay.
How about for overloads?
Sorry, say that again?
How about for overloads?
Of what?
Argument, number of arguments?
Oh, well, then it would just pick the one that matches. If it finds one that matches, then it would be, yeah, I'm sure it handles it. It'll handle that case. Yes, you can use, I mean, well, we're using generics right here, right? The method signatures can definitely have generics on them. And you'll see that if you actually look in the JDK code base, you'll see that they do that a lot. So again, the signature of the reference method needs to match the signature of the functional interface. So here's, what about a constructor? What if you want to reference a constructor? So for example, let's say you end up writing a function here. We're using now a different interface. It takes a string. It's a function that takes a string and returns an integer. And what we're going to do is say x new integer. Just pass a string to new integer, and that should work. And what we do here is we can then call mapper1.apply pass number 11, and it's going to return us an integer object of 11. So you could write it that way, but again, you could also write it this way. So you could say integer : new. And what that's saying is that we would like you to create a function. This is what you tell the compiler. Mr. Compiler, please create me a function which has a method, and that method is going to take a string and is going to return an integer. And in the body of that method, invoke the new constructor on integer and pass it the passed-in parameter. So the first few times you see code like this, you're going to have to OK, let me write down on pen and paper, what is this code doing? So until you get used to it. OK, comments, questions? Right? So where this is quite useful is when you're working with streams. You'll find that this becomes incredibly useful. What about if you wanted a specific method? So let's say your Lambda expression now was a consumer that went out to system.out. Now system.out is as an object, right? It's a specific object, and you wanted to call the println method on that object. Can you replicate the same thing with a method reference? Yes, you can. You could just do it this way. System.out : println. So you're just putting the actual object reference that you want to invoke the method on. But you're doing double colons like you would in C++. But yeah, that's kind of. Okay, questions, comments? Yeah.
In the previous slide, you didn't specify a parameter u. Do you not need to do that?
I don't need to do that because that's implied by the function signature. Because when you look inside of the function interface and you look at the method that's defined there, it takes a string and returns an integer. So it's implied that whatever parameter is being passed is going to be passed to the constructor. Okay? All right, so that's how you do it for an object. You can also reference a specific method. So let's say you had x and you wanted to call x.toUppercase. Instead of writing x arrow x.toUppercase, you could say string : .toUppercase. And what that means is invoke the toUppercase method on the parameter that's passed to the Lambda. So when you call mapper2.apply with def, it's going to take the def string and call the toUppercase method on that. So the whole idea of takeaway point here is that the whole idea of method references is if you already have a piece of code that you've already written, you don't need to just ceremonially type a one-line Lambda expression that just turns around and calls it. You can just use method references to point at it and say, the body of this Lambda is really defined by this other method over there. Yeah, question? It kind of has to, yes. Yeah, so the question, does it type check that that method is there? Yes. You can't just go here and say string : xxx to be like, there's no xx over there. Yeah. No, on the derived class. Because it says this is the instance method reference to arbitrary object of a particular type. So if the type that you pass into it has that method, it calls the most specific implementation of that. And if that was from a base class, or it was from a derived class, it'll do the right thing, just as if you had written it by hand. Okay, great question. So here's a summary. In the interest of time, I'm going to go like that. Right? You can look that up online. So that brings us to the last topic, which is like involving new language features. Okay? So in terms of new language features, we saw the arrow notation for lambdas, and we saw method references, which was new language syntax. So the next thing we want to look at is default methods. And those are awesome. Like, that's my favorite feature in Java 8. Forget lambdas. That's great, but default methods are just freaking awesome. Here's why they're awesome. Because because of the interface evolution problem. So when they built the lambdas, they're like, OK, we need to use those with the existing Java util libraries, right? Lists and maps, that's the natural place to use them with. But all of those things are defined with interfaces, right? We've got iterable, collection. And if we go and we add methods like for each, which I already showed you, if we added for each method to one of those interfaces, everybody who's implemented that interface has to provide an implementation of that method, right? So old code that's already compiled will not work with new version of Java. That's a no-no. So they're like, it has to be binary backward compatible, which means there's got to be a way now to add a method to an interface and provide the implementation of the method in the interface, so as to provide the ability to be backward compatible. So the problem that they solved with the default method is, how can published interfaces be evolved without breaking existing implementations? So I'm so excited about it because I have published interfaces where I could use this. So let's see some examples of that. So a default method is, on a Java interface, provides an implementation body that goes with it. So let's say we take iterable. This is actually from the JDK now. Okay, this is code copy and pasted from the JDK. So we know that iterable used to just have a single method called iterator, right? Now it has this extra method. Go ahead and read it. It should make sense at this point. So who's now understands how for each is implemented? There it is. That's the code for each right from the JDK. Copy and paste it. Objects require not null just checks to see that the parameter that you're passing is not null. It throws a null pointer exception. So that's all it does. Any questions? Right? Who could write this code themselves without Java 8? So the only thing that's different here is you see it's got the keyword default at the start of it. Yes? This class objects is something new in Java 8. It just has a bunch of utility methods for working with objects. Okay? We don't need to get into it. You can look it up. Here's another one that's there, splitterator. Okay, so that's another thing that all iterators are able to do. They can split themselves up and have children. And the splitterator is pretty cool because it's an iterator that's designed for parallelism. So with the splitterator, you can take something and say split it up into different pieces so it can run on multiple threads. It doesn't have data races. Like, the problem with iterator is you go has next, and then you go next, right? If has next. And what can happen between the if has next and the next piece? Synchronization data races. So we don't want those. Therefore, this splitterator is there to allow you to create streams out of it. We'll talk about that later. Okay, so that's the default method. So what about inheritance, right? Everybody's going like, default methods. This looks like now C++ multiple inheritance. No, it's not. Okay, so let's say we have an interface test, which has a default method, do something, and that prints out test. So keep it really simple. Read the code in the bottom, please. What do you guys think it will print out? Now, what is so special about this? What is the test impl implementing? It's implementing the test interface, right? But is there an implementation of the do something method in test impl? That's the whole point of default methods. You can put the implementation in the interface. And every class that implements that interface inherits that implementation. Can you override it? Wait till the next slide. Great question.
What if you already have it?
Sorry? Yeah, that would be a typo. That's because I cut and pasted those examples from working Eclipse examples, but then I started removing like the little 1 and 2s in there so that it would fit better on the slide. And I clearly missed that one there. Thank you. Yes?
What about name clash?
Name clash. Tell me more. What do you mean by that?
Imagine you have an interface test1 with method do something, and
Yeah.
you have an interface test2.
Wait for another slide. Let's move on then. So how would you override it? So that was the first question that was asked. And the answer is you just override it. You just provide an implementation. And if you do that, it will use the implementation that comes with the class rather than the one that comes from the interface, just like you would with regular class inheritance. Yes, question?
And would that happen in a backwards compatible sense as well? So like say, you've written an implementation of an earlier version of
Do
your
something.
Yes, yes, yes. That's
Somebody came-
yes.
And the interface writers came along and they used
So the question was, what if I already had a class that had an implementation of do something, and then I changed it to I went and changed it to a default.
and no override.
And well, the @override is just a hint to the compiler, right? That doesn't really impact, it's not in the bytecode, right? The @override. So if you take an existing class and you go and you change it to have a default implementation, the existing people that implemented it, they would still use their implementation, which is probably the behavior you would want. Okay, great question. Anybody else? So we can call it, and hey, look, I actually removed the 1s and 2s from there. Yes? Yeah, you can still call the parent one. Just wait, you're going to see one. Okay. So what if I have a hierarchy of them? So I've got my test, and what if I have a test A, which extends test, which is another interface, which now is do something, prints out test A, and then I do this. What do you guys think it will print out now? Test A, yeah. Because it's going to basically, just like inheritance, you take the closest one. So this default method was an override of a previous default method. Who's with me so far? Still following along? Okay, great. All right, let's set up a conflict. Somebody was asking about that. So what if we have test interface A, which has a do something, and an interface B, which has a do something? And then what we're going to do is have an AB impl that implements A and B. Which one is it going to pick? Anybody want to take a guess? Compile error. Okay, guys, read the compile error while I drink more beer. So you don't get any unpredictable behavior. Okay? If there's a potential for conflict, the compiler will complain, and you'll be forced to fix it. So how do you fix it? Well, exactly, override it. And when you override it, you'll see here that what it's doing is I've got in the overridden do something, I'm just calling my own system out println AB impl. But also I'm saying a.super.do something. Somebody was asking, can I call up to the one in the previous interface? And the answer is yes, you can. Yes?
To make that top one final?
What do you mean? Which top one? What do you mean by?
Either of them, an A or B to prevent some of the final method and
Well, it doesn't make sense to make a default method final because it defeats the whole point of it, right? Because if, I haven't thought about that. I'm 90% sure it's going to basically say, that doesn't make any sense. Yeah.
This might pass.
If I had more time, I'd type in that code right now and try it out, see what happens. You're going to have to try that one out. So the question was, if I'd already have code where I've pre-compiled it, and at that point, there wouldn't have been default. Actually, hold on. If it's pre-compiled, they wouldn't have been default methods to begin with, because those didn't exist in previous versions of Java, right?
Right.
So if you did have that in Java 5, what would it do? In just Java 7? You wouldn't have inherited anything from. They would have just been like do something, and I don't even know what the compiler will do now that I've had some beer. So that situation doesn't arise because this is new feature. Yeah. Okay. Oh, what about diamonds, right? Yeah, so was that your question? Go ahead.
No, my question was, this default methods, looks like it doesn't really have anything to do with lambdas.
No, it doesn't. So as we said, like it's a new feature and it solves the general interface evolution problem. So if you have an interface at work that you've been dying to add a method to, when you go to Java 8, you can do that. Yes? Yes, then you would have a problem like that, and then you would have to change something. In fact, okay. Yes, it wouldn't. In fact, okay, so let me see if I can repeat your question. And I remember like seeing something on the Tomcat developers mailing list a couple of days ago, which was exactly that. It was somebody saying, I can't build, oh yeah, it was one of the Debian package managers saying, I can't build Tomcat 7 with Java 8 because of that situation, which can you describe again? Because I've had too much beer.
Say I've already implemented do something, right, in Java 5. Actual 5 signature.
That's exactly what it is. So the thing here is, so to repeat it is, I've already got a do something method here. Somebody comes along and in one of the interfaces they implement, they add a default method called do something, but it has a different type signature. Well, if it has a different type signature, then it's overloaded, but you could get, maybe it has different return type or something. Yeah, you can get into an incompatibility in a situation like that. Yeah. But that requires, it's kind of hard to do. Although I did see that on the Tomcat mailing list. So, all right. What about diamonds, right? So what if I have an interface A that implements do something, and I have an interface C which extends A? Notice that C just has an extra method called other. Now I come along and I have an interface D which extends A and provides an implementation of do something. Who's with me so far? Okay. And now I'm going to do CD impl, which is going to implement C and D. The question is, which one does it pick? Which do something do you get? Were there some shirts to give out? Would this be a worthy question for a shirt? All right, so whoever gets this one right gets a shirt.
There we go. A nice NewCircle.
All right, so somebody shout out an answer. D, he gets a shirt. So, all right, so one shirt has been given out. So in this case, what's happened is it takes the one that's closest in the graph. So in this example here, the D is closer than the A, implementation of do something, if you're walking up the inheritance tree. Okay, questions about that? And if they were at the same level, you'd get a conflict, and the compiler will force you to override that. So you don't really have these classic multiple inheritance diamond problem. Okay, comments, questions? Okay. Okay, please read that while I drink more beer. No. The question was, does the default method have access to this? The answer is absolutely not, because, well, actually, hold on. Does it have access to this? Yes, because you can't. Okay, it has to have access to this because you can call methods that are defined on the interface. So you can have one default method call another one. If we go back in time to the iterable here, right? In this case, like inside of the for each method, you could have called another method like that was defined here. In fact, you are, because you're having, there it is right there, this, right? And it's the this here, the compiler is turning that to a call to the iterator, because it turns this into a regular for loop, right? So the Java, the libraries, the compiler, it's all kind of mishmashed together now. It's like there's things in the language that are really in the libraries, and yeah, it's going to be like that for a while. It'll never change. Does that answer your question?
Yeah, partially. So then, what if I have a protected variable in my disk?
Well, where would you define the variable? If you try to define like a private something there, the compiler will complain. It's not a class.
In the implementation of this?
Well, but the compiler, when it's compiling this code, doesn't look at the implementation. It just looks at that interface. So if you had like a public or a private static public.
Interface does not have this, so technically this should also cause confliction.
Well, the interface doesn't have this. It does, because the interface will have to be realized by a class. You have to have something that implements the interface, right? Now, what if you have an interface with all default methods? I don't know, I haven't thought about that. There's definitely edge cases here that you're going to have to sit and think your way through. Okay? Yes?
Follow up to the dictionary, because
Yes, you'll have a problem. That's he just came up with a scenario that sounded very complicated and very plausible. And I had too much beer to really think it through. So I have a lot more slides to go through. So sorry. Okay, yes?
I do have a question then, though.
Well, the 1.5 compiler would puke when it sees the default method.
Well, if it's just in a library, right?
If it's just in a library. So you want to run a Java 5 compiler against code which is going to link against a Java 8 library, I have no idea what will happen. But that's a recipe for disaster. Okay? I don't know why you would do that. So I don't know the answer to that. Sorry. Hey, anybody else? Any other questions? All right, here's the complete what is a functional interface, which was incomplete. A functional interface can only have one non-default method. Does that make sense now? So you can have as many methods as you want, so long as only one of them was not a default method. The rest can be all default. Right? And that takes that. Oh, so question, are all these concepts clear? So Lambda expression, functional interface, method references, default method. That's the story of the mechanics of how to do lambdas with Java 8. So if you're already an expert with lambdas from other languages, hopefully this has shown you how Java 8 does it. And if you're new to it, hopefully you've learned enough of the syntax now that you can happily go and try this out at home or at work tomorrow. All right, I think we're supposed to go till 8:30, and there's only like 15 minutes left, so we're going to skip the break part. We started a bit late. I was planning a 5-minute body break now. All right. So the collections framework. So the Java 8 uses Lambda expressions and default methods to take the existing collection framework and add lots of functions to it. We already saw the for each statement, which is an example of internal iteration. Rather than writing a for loop, which is sequential, you can use for each, and the for each could do things on multiple threads if it so wished. So that's one thing you can do. But let me highlight some new methods that are there. For example, we already saw that iterable, anything that's an iterable has a for each method that you can use now. It also has a splitterator, which is useful for streams. How many people here, let's just skip here for the sake of time a little bit and go and look at map. Who is very happy to see put if absent? Clap for that one. Finally, put if absent, right? Who's written that code a billion times before, right? Yes? Which one? Put if absent has some threading issues, yes, but you still write a lot of it. And it'd be nice not to have to write it every time. So, we've all done that. It's not there, add it. Yes, it has threading issues. It still does. So you still have to know what you're doing there. So there's on the map interface, there are about 20 new methods, some of which are things that should have been there from the beginning but weren't, and some that are new and fun just because lambdas are there. The stream-related methods are these ones here, and I want you to point your attention to the fact that there's something called stream and parallel stream, and I'll tell you what that does later. Parallel stream will do it on multiple threads. That's how easy it is. So the question is, what is a stream? This is probably a new concept to most of you. It's a functional programming design pattern. Just like strategy pattern and command object are all like regular object-oriented patterns. And it's about a way of processing elements sequentially or in parallel. If you look at your code, you typically do something like maybe you write a database query, you get a list of objects, then you iterate over that list, you produce a single result. Or you iterate over that list and produce a map. Or you iterate over the list and produce another list. This type of looping over data structures, who's got lots of that in their Java application? And what streams do is they make that easier to do. That kind of code is a lot easier to write with streams. So streams are a concept, and because they are a design pattern, you can implement streams in C#, you can implement them in C++, you can implement them in whatever language you wanted to implement them in. So let's look at what makes something a stream. This is an example here. Let's say I've got a list of orders, and I want to calculate the total quantity of online orders of a certain thing. So what you do is you call the collection orders.stream. And what that does is, OK, so let's do it with the bullet points. So first you create a stream instance from a source, which in this case is the collection. That's the orders.stream. Then we add a filter operation that checks to see we pass the Lambda expression that says, look at the incoming object, get its type. If it's an online order, then let it through. If it's not an online order, drop it on the floor. And then you can, and that the streams always have a pipeline of intermediate operations that you can do. Then we're doing a map, so we're taking the object and we're extracting out of it o.getQuantity, so we're getting how many items were in the order. And then finally, we're adding them all up with the terminal operation called sum, which will add it all up. So if you didn't have this if you didn't have the streams, how would you do this with regular Java code? Write a for loop, right? If statement inside the for loop for the filter. And then inside of the if statement, call the getQuantity, accumulate that in a variable defined outside the loop, and then return that. That's more lines of code. So streams will make it very compact to do manipulations on data structures. So here's a picture of how to visualize every stream. You've got to have a source, a pipeline, and a terminal. And because you have to have the structure to the stream, what you have to understand about it is it has a life cycle. Okay? So with a stream, you have to first create it. Then you have to configure it, as in configure what is the pipeline, what is the source, what's the terminal operation, and then you execute it. And until you actually execute the stream, nothing happens. So when you look at this code here, it might look like you're looping over things twice. You're not. It actually doesn't do anything until you invoke a terminal operation. So it's lazy. And then finally, the stream has to be cleaned up. Now, streams can only be used once. They get exhausted. So once you execute and the stream does its thing, you can't just use it, like invoke it again. You'd have to go rebuild it, reconfigure it, re-execute it, re-clean it up. So let's take a look at some stream sources, just to kind of give you an idea of what is a stream source. Here's a stream source that is a range from 0 to 5. And we're just for each printing it out, so it just prints out 0, 1, 2, 3, 4. Just an integer stream. Streams can be anything. What a stream does is spits out elements. So that's not a very interesting stream, right? But it's a simple one. Here's a collection stream. This collection stream takes a list, and it turns it out as a stream. And you can see that by calling cities.stream.forEach system out println, we're just printing out the cities that are in the stream. So any collection can act as a stream. Why is this useful? It's incredibly useful because when you start setting up a pipeline to manipulate the collection, you can do fancy things like filter it, map it, reduce it, do computation on it, calculate statistics, sort it, do all sorts of really fun stuff. We'll see what some of those are. Here's a nice little character stream. Okay. So you just take a string ABC, call .chars, and in this case, the terminal operation is count. So we're actually asking the stream's terminal operation to count how many things passed through it. So that returns 3. Hey, that's not as fast. That's way slower than calling string like length, but hey, you can do that. All right, here's some fun streams. Okay, pay attention to those ones. I know it's getting late here. I've got 10 minutes to get through the rest of the slides. So in this code here, I'm asking the process to figure out the current user directory, right? And then I'm turning that into a path object, which is from Java 7. And then what I'm going to do is, if I then call files.list, and I give it a particular directory path, what it gives me back is a stream of all the things in that directory. Who's used the Java file object to get all the files in the directory, right? You get back an array, then you have to loop over it. It's really annoying, right? I hate working with that object. And now you can just say, well, the files in a directory are a potential source for a stream. So you should be able to just grab stuff from there. Here's another one, files.walk. And what this does is it does a depth-first search starting from that directory all the way down. And whatever it finds, it returns each item as something out of the stream. And then whatever processing pipeline you could do, you can set that up. So for example, I'm not putting anything in between here, but inside of the for each, perhaps you are figuring out the size of the file. Or you could have a map to an int where you take the file and then you calculate its size, and then you have a sum at the end and you calculate the size of all the files in a particular directory, as an example. Comments, questions? Was there a hand up there?
Are streams reproducibly ordered?
What do you mean by that? What
Well, are they predictably ordered?
are streams? So the question is, are streams predictably ordered? The answer is, it depends on the source that you are using. So for example, if you used a range source, and the range source was from 0 to 5, right? It's going to start from 0, 1, 2, 3, 4, 5, and it's going to run like that every time. On the other hand, if you're using this files list stream, it's going to depend on whatever is in that directory, right?
But if I don't change the directory, the next time I get that stream,
You'd have to read the definition of the source.
okay.
You'd have to read, there's nothing in the stream that says there's a certain order on the things that come out of the stream. So the stream interface doesn't say that there's an order, but the implementation of the stream source could imply an order, such as, range stream.
But it's not, the stream contract itself is not.
No, not that I know of. Yeah. All right. So for another shirt, we have another shirt to give away? All right. For another shirt, what does this code do? If you understand this code, you got everything there is to understand today. You can pat yourself on the back. All right, don't scream out the answer if you know it. Let's give everybody a chance here to process this code. All right, so does anybody know? Raise your hand if you think you know what it does. So I just want to see until I get like 10 or so hands that that was enough time. All right, now whoever can shout what it does first really fast gets the shirt. Print source code, that's correct. Yes. All right, was that a question earlier, or you knew what it does? Okay, so this is a program that prints itself out. So let's see how it works. Okay, so we have our standard method main, and this will only print itself out if you run it from inside Eclipse. Okay, because the working directory in Eclipse is the project directory where the code is. So I'm assuming that if I get a handle on the process working directory or the current directory, it's going to work. Okay. So what I'm doing here is I'm basically taking the class name, replacing all the dots with forward slashes, and adding .java to find the name of the Java source file. And then I'm kind of call the find method on the files object. And the find method is a stream source. Okay? And what it streams is a list of files that match my criteria. So I give it a directory to look at, I give it a maximum depth to walk, and I need to give it a predicate to decide whether something is considered found or not. Since I have to give it a predicate, what's a really good thing to express a predicate? Lambda expression, of course, right? So that's the Lambda expression here that says, now the Lambda expression takes two parameters in this case. We're given the name of the file, And we're given the file system attributes like read only, write, and stuff like that. So in this example, the only thing I care about is, since the file name is a string, is does the file name end with the class file name that I created earlier? So who's with me on that? Yeah, question in the back? Yeah, I could, but then that would take more lines. It wouldn't fit on the screen. When you write code for PowerPoint, you write things that just you hope that it doesn't spill over into multiple lines. So, okay. So now, this first Lambda expression here is picking up, making sure that I find the source code for this file. And then, since the find method returns a stream, I could put a for each terminal on that. And the for each terminal is going to do something for each thing that's found. Well, the thing that find returns are path objects. So I take the path, and then I go back to files, and files has another stream called lines. And what lines does is it will take a text file and return to you all the lines as a stream. So each item coming out is the next line of things. Who's happy about that? That's so much better than doing it the old way. So one line. So then all I'm doing here in this case is just calling dot for each and then printing it out. Now notice that I have to use a try catch here because it throws an IO exception, and I can't throw it out and filter it. No, so I just put the try catch. That does nothing. Again, for the purpose of PowerPoint, it does nothing. Okay. Who's now understanding what this program does? Okay. Hopefully this is giving you an idea of A, how lambdas work in Java 8, and B, the kind of code you can start to see yourself writing with Java 8. All right. Comments, questions at this point? Oops. Right. So stream structure, source, pipeline, terminal. We already talked about that. Some of the terminal operations that you can have, reduction terminal operations, mutable, search. Okay, let's just look at some examples. Important point in red. Nothing happens until the terminal operation is invoked. So let's say you want to count stuff. You just go integer stream.count. This is a stream that has a source, it has a terminal, but it has no intermediate operations. Everybody clear about that? You don't have to put any intermediate operations. It's great if you do, but you don't have to. Here's a stream that calculates the minimum value in the stream. So in here, the lambda expression is a comparable, right? So it returns -1, 0, 1, so just subtract the two integer, it works. But that's kind of annoying to write. So instead, you can just go to the comparator class and say, I'm comparing integers. So there's all sorts of little utilities they put in there. So the libraries have all sorts of things to just make your life easier. It's going to take some time to absorb all of those details. Here's another one that does a reduce. And that means take everything and just, in this case, is just adding up all the items in the stream. So reduce returns a single result out of a sequence of results. Mutable operations. This is important to understand, and this might be the last thing I'm able to do today. We'll see if people want to leave or stay. So what if you wanted to process a stream, and what you wanted to do is collect all of the things that survive the stream pipeline, and you want to put them into a list, or you want to put them into a map, or you want to put them into a set, right? Who can see that that would be useful? That's the job of the collect method. Now you can see that the stream.collect terminal is being passed an object which is an implementation of a collector. Now the collector is like it's like there's a whole bunch of them. So you can go collectors.toSet, collectors.toList, collectors. I probably have some here. Collectors, list, set, map, grouping by, partitioning. There's all sorts of fancy collectors that you can do. So if you just had a data structure, a list, a map, and you wanted to do some processing and send it to a bunch of different places, you can turn it into a stream and then use a collector to send it to those places. And you can pass predicates to the collectors and all sorts of fun stuff. You can also turn something into an array. Okay. As far as like there's some search terminal operations like find first. Find me the first thing that the stream gives, and then stop. Maybe you're just looking for the first file in a directory that matches something. find me something, anything that matches, check the stream, and is there anything that matches the condition x is equal to 5? Yes, there is. There is a value 5 in the stream. Check if any of them are greater than 3. Find anything. Find any is completely unpredictable. It can return anything. It says it doesn't matter. Just find me anything. And the reason why it's an unpredictable result is if you have multiple threads. Streams can be parallel. And if you have 3 threads running, and the first one that produces the result gets to deliver it. So the next time you run it, different thread might win.
Why can't we follow
Which one?
x greater than 3? X greater than 3.
Because I made a typo, and that's not supposed to be any match. That's supposed to be all match. I copy and pasted wrong, sorry. Okay, for each we already saw. So let's see if we can quickly, in 2 minutes, talk about stream pipeline rules. You can process elements sequentially on unparalleled, and the rule is you cannot modify the source of the stream while you are processing things on that stream. Otherwise, all the bad things happen. So how exactly that works with like a file system stream, which could be being modified while you're doing stuff, there's a lot of details in the docs that I haven't gotten around to fully comprehending. But that's to be determined. As far as the intermediate pipeline of operations go, they fall into 2 broad classes, stateless and stateful. The stateless operations don't really need to know anything about what's come before. The stateful operations need to know. So for example, if you wanted a stream that sorted the items, obviously you need all of them before you can sort them. And if you have things like parallel operations, then you have places where the threads might need to wait on each other and all that other kind of great jazz. Again, there's a really great presentation from Java 1 called Streams and in Top Gear, or something like that, and it really goes into all the gory details of this. So I'd recommend you watch that on Parlays. So let's look at some examples here. Filter, so for example here, I just want to find all the things that are less than 4, so you pass it, it's going to print out 1, 2, 3. If you want to map it, like in this case, increment each item by 1, you just call .map, pass in a Lambda expression that does that, and collect it to a list and print it out. You can do something fun like summary statistics, which will calculate average, median, mode, standard stuff on the list that you pass it. And in this case, I'm mapping it to an int and doing nothing there with a unit mapping.
Is that a Java 8 method?
All this compiles.
Summary statistics?
Yes.
Yeah.
Yes, this is all compiles and runs. I like the stuff in green, I cut and pasted from the Eclipse console. Except when I edited it in there, you see my typos, right? So intermediate other stuff, okay. So these are the stateful ones. Like for example, I got 2 5s on the list there in this stream. And if I call distinct, it's going to kill one of them, right? So distinct needs to know what it has seen before. How is distinct implemented internally? It could, who knows? I haven't looked at the details. This is where, thankfully, we don't have to know those details. Just like, do you really want to know the gory details of how concurrent hash map works? I've heard there's only like a few people in the world that understand that. So limit is basically going to say, take the stream, but I'm only interested in the results of the stream up to the first 3 results. So in our case, that would be like 1, 2, 3. Okay, so you're limiting how much of the stream goes through. Skip is going to say the first few results, in this example, skip the first 3 things that pass through the stream, and then give me everything after that. Sorted, well, that's what its name says. It sorts stuff. Okay, so does this make sense? This is, I think, the last slide in this. Yeah, so the details, the implementation details are all in the Java docs. You gotta have to write code, test it out, see what it does. Yeah. There's a lot of details that we're not covering. I mean, it's very ambitious to try to cover everything we've done so far, like both streams and lambdas in like an hour and a half is really a lot. So hopefully I've somewhat succeeded. So who thinks they're understanding what this does, right? You're looking at it, it's like, yeah, that kind of makes sense, right? We're going through, we go to our order service. Notice that Now, your order service or typical services now, they would return lists and data structures. In the future, you'll probably find that it might be smarter to just return a stream. Who would like JDBC to do that?
Yeah.
The whole paging problem goes away, right? Or would be expressed in a different way. Optional double, okay, we're filtering it. Give me all the orders where the order has more than 2 items in the order, and find out what the total for the order was, and then terminal operation is give me an average of that. So that would have been probably 20 lines of Java code with some intermediate collector data structures. Here's one, just the same thing, just a little bit more complicated to make your eyes get confused. See if that makes sense.
What if item size is 1?
Sorry?
The item size is 1.
Then it would be filtered out. It would be dropped. It wouldn't be included. It wouldn't go to the next stage in the pipeline. So if the item size was 1, it wouldn't make it out of the filter to the next stage. Right?
Like on the substrate.
So in this case, all I did was I just replaced the the order : total method with what the order total method does, which is to say, take an order, get its items, which is a list, turn that into a stream, take each one, map it to an integer, and the way we map it to an integer is we take the item, we take its quantity, we multiply it by get me the product that the item is of, then get the price of that product, then take the whole thing and sum it. So you will be able to write really convoluted looking code that will guarantee your job security for a long time. So with that said, I think the last thing to say is parallel streams is if you just say dot parallel stream at the top, what the Oracle says will happen is it will all happen on multiple threads. And you don't have to know anything. It will just happen on multiple threads. Yes, question in the back? So the question is, in production code, some stuff will be null, and then you'll end up with all sorts of stuff, right? So the answer is you might want to then put a filter to drop out the null items. And it's going to be fun putting breakpoints in that kind of code. I haven't really tried too much of doing that. I mean, those are the kind of practical things that I think will become very obvious over the next few years of how well it works in real life. Yes, question?
Yeah, I think that it really depends.
All right, so yes, I'm trying to find one of those here. Yeah, here we go. So if you look at this example here, this is a really great comment. Thank you for that. You see that what's coming out of the stream find first is an optional. Because maybe the stream is empty and doesn't have anything, right? And you don't want to return null because the next thing will crash. Now, optional is a new interface. It's a new class. And it just means that if something returns null, instead return an optional, and then you go optional, check if it's in there. If it's not, then return it. But of course, what do I do in my code? I shouldn't say this, but if I have a lot of beer, I just go optional.get. I bring back the problem again. Okay, yes, go ahead. Yeah, I mean, like the patterns for how to use Lambda well are going to emerge, right? I don't know what those are. I haven't written enough Java 8 code to be able to tell you exactly what are the best practices yet. So talk to me in like 3 years. Let's go back to the last one, I think, parallel streams. So in summary, here's what I want you to remember about streams. Streams have a source pipeline and a pipeline of operations, and then a terminal operation. And then the stream lifecycle is create, config, execute, cleanup, and that's it. Thank you very much.